Okay, so I'm Bryce Jech. I'm a web developer at the Oklahoma State University Foundation, and today we are going to be talking about Git and GitHub. Most of this talk is going to be really instructional, and we're going to be actually going through a lot of examples ourselves. So I want to make sure that everybody has a GitHub account and has Git installed on their machine. All of the examples that we're going to go through, we're all going to go through them together. I'm going to go through them in my terminal. I want you to do the same, especially if you've never used Git or if you're not familiar with it. It takes a lot of practice to kind of get some of this down, and so the more that you exercise that muscle, the better you're going to be at it, and the more you're going to take away from today. So if you don't have Git, you can get it at git-scm.com. You can run it on Mac, Windows, Linux. You probably already have it. But just go to git-scm.com and then go to this download link here. Oh, looks like one more. Okay, so what is Git? Git is a distributed version control system. A version control system is an application that allows programmers to manage changes to their projects over time. Here the word distributed means that there's no central server where a project's source code and history live. When we clone a Git project, we're making a copy of it on our local machine. You're going to get a copy of the repository in its current state and all of the history for that project going all the way back to when it was first created. Having the entire project history stored locally on your computer makes for extremely fast operations because it doesn't have to communicate with any central server like it would for like Subversion or SVN. So you may never have used Git before. You may be wondering why you should be using it. If you're the only person working on a project, then you might ask yourself why really bother with it. You may have a project that you've been working on where you take regular backups at points where your code has changed significantly. One day you decide to start working on a new feature. You implement the feature and take a backup of the project. The next day you decide that the feature you just implemented isn't going to work out, and so you remove it. You continue working on the project for several weeks, taking regular backups along the way. At some point, though, you decide that the project's in a stable state, and you decide to remove the old backups that you created. Later, you remember the feature that you'd worked on a couple weeks ago, and you decide that you want to give it a second chance. Problem with that, though, is that you've already removed the old backups. Even if you had kept them, you probably aren't going to be able to remember which backup it was that contained the feature. So it may just be lost, or it may take a significant amount of work to recover the feature that you were working on. This problem is exacerbated when more people work on the project. It's inevitable that at some point, someone's going to delete or overwrite a file that you may have been working on. Maybe you guys are sending copies back and forth through email. You can just go back through some of those old emails and try and find the code that you were working on or sharing, and it never works. You're not going to be able to find it. Good luck, but Git is much better, and that's why we're going to be working with it today. So the first step to using Git is to download and install it. I hope that everybody has all of that ready to go, so we're just going to skip over this section. I do want to note, though, that there are some graphical user interfaces that you can use with Git. There's Git Kraken, which is available on Linux, Mac, and Windows. SourceTree is a really good one. GitHub Desktop, Tortoise Git. There's a lot of them. These are just kind of some of the most popular. I've included links to all of the download pages for each one of those in the README. Okay, so once we've installed Git, the first thing that we want to do is make sure that we have our username and email configured. This lives in Git's global configuration file. You can also specify it at the local repository level. This information is going to be added to each commit that you make, and so it makes it easier to figure out who's created a commit, who's made a change to the code base. We can view the global configuration for our username and email with git config global user.name, and that'll spit out the value of that key. Same thing for email. If we want to set that value, we would say git config global user.name, and then our name, like this. Okay, so the first thing that we want to do is we want to navigate to a directory where we're actually going to create and house our Git repositories. By default, this is usually in your documents folder. So I'm just going to go to my home directory, documents, and then here we've got our GitHub folder. So once we're in there, we're actually going to initialize a new empty repository. So we want to make a new directory that's going to house this. We're going to use the make dir command to do that, and we're just going to call it my project. I was working on this last night, so let's remove that and start over. Okay, so we want to make a directory, my project, and then we want to change to it using the cd command. And then we're going to initialize an empty Git repository using the Git Init command. Now here Git's going to tell us the path that it created the repository in. So this command, it initializes a new repository in the current directory. You can optionally specify the full path to the directory you want to create it in. If you don't specify that, though, it just uses the current working directory. So if we use the ls command to view all of the files that are in our current directory, we should see a reference to the current directory, the parent directory, and the new .git directory that was just created. This .git directory contains all of the information about your repository. It contains all of its history, the object database, all of your settings, and a whole lot more. It's way outside of the scope of this talk to get into the Git directory, but I have provided a link here that you can use to learn more about it. So before we really start working with Git, it's really important to learn about the different states that files can be in when you're working with it. These states are committed, modified, and staged. Committed means that changes have been safely added to your local Git database. Modified means that a file has been changed, but it's not yet been added to the staging area. Staged means that you've marked a modified file in its current state to go into your next commit. So each one of these states is directly related to the three main areas of a Git project: the Git directory that we talked about a moment ago, your working tree, and the staging area, which is also called the index. So the Git directory is where Git, like I said, stores the object database and all of the metadata about your project. This is the most important part of Git. Without this folder, you don't have a Git project. The working tree is a checkout of one version of the project. In our case, this is a checkout of the master branch. We'll cover more on branches later. But this is where this is your working directory where all of the current state of your project lives. So everything inside of this My Project directory here, that is our working directory. So the most basic Git workflow goes like this. You go in and you make some changes to a file in your working tree. You use the Git Add command to selectively stage the changes that you want to be part of your next commit. And it's really important to note that Git adds only those changes to the staging area. So if you modify a file and use Git Add to add it to your index or your staging area, only those changes for that file are going to be a part of your next commit. If you go and change the file after you add it, then it's still just exactly those changes that you originally added. If you want to update your staging area with the new changes, you have to go add the file again. The next step, you make a commit, which takes the files as they are in the staging area and stores a snapshot to your Git directory. So before we start actually making some commits to our new project, we're going to use the Git Status command to view the current state of the repository. So here Git tells us that we're on the master branch, that we don't have any commits yet, and that there isn't anything to commit. So it does a scan of our local directory and says, well, nothing's different since I was created, so there's really nothing to do here. Okay, so let's go ahead and make our first commit. We're going to create a new file. We're going to use the echo command here, and we're going to say today I am learning about Git. And we're going to send that to a file called index.txt. So this creates a new file called index.txt, which contains the string that we typed in above. So if we do another status check using git status, it's going to tell us here that we still don't have any commits, but it has picked up a new untracked file. And it's saying here that index.txt is there, but Git's never had it in a commit before, so this is what's called an untracked file. Okay, so the next step is going to be to add this to our staging area. We want to use the Git Add command to do that. So we're going to add the file index.txt. Now, if we do another status check, you see that we've got a new heading here, right? It says changes to be committed. So what this is telling us is that the index has our changes, our staging area has those changes, and whenever we run the git commit command, all of these changes in here are going to be a part of the next commit. It's important to note also that we specified an individual file, but this can be anything. You can pass it a directory, you can pass it multiple files. If you had like a index.txt, index.html, main.cs, you can do it just like this, or you can specify the current directory. Any file-like object will work with the add command. Okay, I kind of already went over it, but I just want to reiterate. It's important to note that the add command adds your changes to the staging area as they are. Any other modifications to the files are not added to the next commit unless you explicitly tell Git to do so. You can, in some cases, have the same file appear in the untracked changes section as well as the changes to be committed section. If it helps you, just think of the add command like saying add precisely these changes to the next commit rather than adding a file or folder to the next commit. Okay, so let's go ahead and commit that index.txt file. We're going to use git commit. We're going to use the m flag here, which is our commit message, and we're going to say that we added index.txt. So here Git reports back to us that we've created our commit. In this instance, it's the root commit or the first commit. It spits us back our commit message that we just used and kind of tells us a little bit about what happened. So all of your commits should have a commit message using that m flag. It's important, though, to make sure that your messages describe the change that occurred in that particular commit. Giving really good descriptive commit message is going to save you a lot of time debugging in the future. It makes it much easier to track down commits that may have introduced bugs or that you're trying to locate for some other reason. Your commit messages should also be really short and concise. You'll see here that while we added index.txt, I usually will use the present tense because we can save a couple of characters. If you can make that short and also very descriptive, that's really the best way to do these commit messages. If you need more explanatory text, then I can't remember what the recommendation is. It's something around like 50 characters. Any more than that is too much. It's going to get truncated when you go to view it. If you need more than that, though, you can specify multiple messages. So we could say git commit m, we'll call this like title, and then you can specify another m flag and give it some more descriptive text like this. You can do that as many times as you want, and each one of those is going to appear as a new line in that commit message. And you'll see why that can be important here in just a minute. Okay, we do another Git status check, and here it tells us that we're on our master branch, there's nothing to commit, and that our working tree is clean. This means that we are in a clean state. If we wanted to switch over to a different branch, we could do that. Basically, Git's saying that you are all caught up and all committed, and you are in a safe state. Your working tree is clean. So we can also bypass the staging area. Sometimes you don't want to add those files individually. Sometimes you may just want to say, just add all of my changes and here's my commit message. You can pass in the A flag to do that here, and that will just bypass the staging area entirely. You want to be careful, though, when you use this because It will only add changes to files that it's already aware of. So if this is a new file that you've created and you do a git commit with an A flag, it won't add that new file. It has to have been a file that's already been tracked previously by the repository. Okay, so let's move on and talk about branching. Git allows us to create what are called branches. A branch is a symbolic reference to a single commit. By default, a Git repository is going to have a single branch, and it's called master. A branch is really similar to a tag, which is used for versioning. Both are references to a single commit. However, branches differ in that they're designed to be updated, while tags usually are just a reference to a single point in history. This is what we use for like creating a release. So when we check out a branch, the working tree is updated to reflect the state of the repository for the commit that that branch points to. When we make a commit on a branch, the reference or pointer for the branch is updated to point to the result of that commit. Branches are really central to the development of a workflow, or to the development workflow in a Git project. They're used to isolate code while we work on new features or bug fixes. Creating new branches allows us to work on a specific task independently without affecting the main repository, or without affecting the main branch, the master branch usually. Once we've finished our work on a branch, we can merge those changes back into some other branch. Sometimes this is master, sometimes it might be a branch that's used for a release candidate. Sometimes, though, the changes in the branches that are being merged are incompatible. This is what's called a merge conflict. We're not going to cover merges. We're not going to cover merge conflicts right now, but just be aware that this can happen, and then you have to manually resolve them. Essentially what it is, though, is say you have two files, or say you have two changes in the same file that occur on the same line. We don't want Git to make the decision for us which one of these two versions of the file is the appropriate one. We, the coder, need to go in and resolve that and tell Git, yes, I want my changes, not their changes, or vice versa. So if we want to view the branches that we have on our repository, we use the Git Branch Command. Right now we only have a single branch called master. You'll see here that it has an asterisk beside it. That's to denote that this is the branch that is currently checked out. We can create a new branch and switch to it. We also use the Git Branch Command to do this. We're going to create a branch called test branch. When we want to switch to that branch, we have to check it out using the Git Checkout command. So here it says that we've switched to branch test branch. So now if we run the Git Branch Command, we're going to see two branches in here now. We've got our master branch, and we've also got our test branch. And here, the asterisk appears next to the test branch because that's the one that we have currently checked out. Git also provides us a shortcut. If we want to create a new branch and switch to it in a single command, we can do that with the checkout command and pass it a B flag. So if we say git checkout B and then whatever the new branch name is, like dev branch, that would create a new branch and immediately switch to it. Okay, it's important to note that in most cases, Git is not going to allow you to switch branches if you have any changes in your current branch that haven't been committed to the repository. Before switching branches, you either have to stash those changes or make a commit. The only instance that I've found so far where it will let you switch branches with a working tree that has any unstaged changes in it is if you add a new file. If it's a file that hasn't been tracked before, then Git will allow you to switch branches, but otherwise, if it's a change in a file that Git is aware of, then it will not let you switch branches. You have to make sure to commit those changes or stash them. So we're still on our test branch here. Now I want to create a new file and create a new commit on this branch. So we're going to create a file called test with the content, this file only exists in the test branch. So now if we run an ls command, we can see that we've got our index.txt file that we created earlier, but we've got a new file called test.txt. If we inspect its contents, we'll see that it has what we just typed into the terminal there. So let's add that file to our staging area. And then we're gonna commit that. So here Git tells us that it's created a commit on our test branch. It's going to give us an abbreviated hash of the commit, and it's going to spit out our commit message that we gave it. So hashes isn't something that we've talked about yet. Essentially what this is, it's a Git takes the state of the repository and runs it through a hashing algorithm that spits out a unique identifier based on the contents of that file. That way, as you know, if there's any changes that have occurred from commit to commit, you're always going to get a unique identifier because the hashing algorithm should generate unique output based on unique input. You know, the same data in is going to get the same data out, but different data in will not get the same data out. So we use this as an identifier to identify our commits. Okay, so we've got our index and test files in there. Let's see, did we create the commit? Yes. Okay, so now what I want to do is to illustrate that the Git Checkout command updates the contents of our working area, I want to switch back to the master branch and see what's in there. So we're still on our test branch. And if we do an ls command, we're going to see that we still have our index.txt and test.txt files. But if we check out our master branch using the Git Checkout command, we've switched over to master. We can inspect that. Master now has our asterisk here. So now if we run an ls command, all we see is the index.txt file. The test.txt file is gone. And that's because it lives on that other branch, but whenever we checked out our master branch, Git went and updated that working tree to reflect exactly the state of the repository when we made that first commit. So that's really important to kind of be aware of, that your working tree is updated every single time you switch branches. And that's what we want. We want to be able to work on different ideas or different parts of our software independently of one another. And that's what this whole branching concept is for. So in order to get those changes, though, from our test branch into our master branch, we have to merge them in. We'll cover merging in more detail later, but just know that there is a really easy way to get those changes moved over to the current branch. So for right now, I want to go ahead and delete that test branch. We're done with it. We're going to use the Git Branch command again, and we're going to pass it the D flag and the name of the branch. So here, we use the D flag to delete a branch. Typically, though, you're going to use the D. It's going to be a lowercase d. But Git will not allow you to delete a branch that has unmerged changes unless you force it to do so. So the lowercase d is kind of a safer way to delete the branch. It will only delete it if your changes from that branch have been merged in to your current branch or to a branch maybe. I'm not quite sure. But here we've given it the capital D flag as kind of like a firmer delete. It's like, I don't care that this hasn't been merged in, I just want to delete it. You do need to be extra careful though, because as you saw, Git didn't warn us like, hey, you're about to force delete this branch. So just be careful when you use that capital D flag because you can lose what you have in there. There's almost always a way to get work back in Git, which is fantastic, right? We're going to cover that later, but we could still recover what was in this test branch, but it's just a little bit harder to do so. Okay, so now let's talk about some really basic operations on the file system. We're gonna talk about removing files, and then we're going to talk about moving files. To remove a file from a Git project, you have to explicitly remove it from your staging area and then make a commit. To do this, you can use the Git Rm command. This will remove the file from your file system and stage its removal for the next commit. So we're going to create a new file. We're going to say I'm about to be removed. Here we have to escape that single quote. That's why that looks funky. And we're going to pass that to remove.txt. So now if we look, we've got an index.txt and remove.txt. So now let's add that file and then make a commit. Now let's use the Git Rm command to actually remove it. And then we have to make another commit after that. And let's do a quick status check and see what our staging area looks like. So here it's saying that as a part of our next commit, we are going to have a deleted file named remove.txt. So Git doesn't really ever delete things, right? It's really hard to lose data in Git. You can remove a file from your working area, but whenever you make a commit that says that you removed it, what you're really doing is you're adding data to the database to say this file was removed, right? Yes, the file is gone, but it's not like it's the history that file was ever there is gone, and that's important to remember. So the Git Rm command is roughly equivalent to removing the file, adding its removal back to the staging area, and then making a commit. Let's go ahead and commit that we removed it. Okay. So had we not wanted to use the rm command, we could have, or the git rm command, we could have also just typed rm remove.txt and then gone in and added that file back using Git Add. And let's just do that. Let's say touch, which just creates an empty file, remove.txt, Git Add, commit. So now we're in the state that we were before we used the Git Rm file, right? Is everyone following me there? And then we're just going to delete that file. And then we have to add its removal back to the staging area. And then make a commit that we removed it. Okay, so there may be scenarios where you want to remove a file from your staging area, but you want to keep it on your hard drive. You can also pass in the cached option to do this. This is really useful for, say you accidentally committed like a configuration file to your repository. This is something that you don't normally want to store in a Git project because it's usually got maybe sensitive information, usernames and passwords, database credentials, anything like that. You can remove it from your repository, but leave it the way it is in your working area. Okay, so let's talk about moving files really quickly. Git also comes with a move command for moving or renaming files. It's similar to the Git Rm command in that it does a couple of operations for us. What it does is going to take the syntax looks like this here, and it's going to take the file in, it's going to take the from file and move it to the to file and then stage those changes for us. So we're going to create another file called and we're going to say I'm about to be moved. And we're going to write that to move.txt. Now let's add that file and then commit it. Okay, so now that we have it in there, let's go ahead and rename that file using the move command. So we'll say git mv move.txt, which is the file that it is currently, and we want to rename it to moved. So now if we do another git status here, it's going to tell us that this file was renamed. So in our next commit, we are going to be renaming the move.txt to moved.txt. And then we can make that commit. Okay. So now if we do an ls command, we can see that it's now called moved. So this command is still just all it really is doing a couple of file system operations for us. That way we don't have to manually move that file, remove it from the staging area, make a commit, and then add it back in. So it's really just a convenient shortcut for moving files around, just like the Git Rm command. So now that we've made a few commits on our repository, let's talk about how to actually view the history for a repository. Git comes with a log command that's used for viewing the commit history of a project. By default, it's going to list out the commit history of the current branch in order of newest to oldest commits. With no other options given, Git log is going to list out the hash, the author name and email, the date that the commit was created, and the commit message. So if we run a git log here, we can see that we have our most recent commit that I just created, which was renaming that move.txt to moved.txt. And then it's just going to go commit by commit. You can use the down arrow to browse downward through them or up. You can also use page down and page up here. When you want to close this out, you can type Q, and that will get you back to your terminal prompt. So Git log is pretty useful by itself, but it comes with tons of options that make it really easy to find what you're looking for. If you want to view less information about each commit, you can use the one-line flag. This outputs the abbreviated hash and the commit message. If you want to view a single line of output with the full hash, you can also pass it the pretty one-line option. This is the way that I usually prefer to read my history. I just want to see just a little bit of information. Usually I'm just looking for the commit message and the order that they came in. So this is just a lot cleaner. There's a lot less information. I can quickly scan through and see what all of the commit messages in the history say. So you can also really customize the output from the git log command using the format. We're not going to go over it here today, but I've provided a link here that you can go and read about it on Git SCM. The formatting options available are really powerful, and you can really customize the output of the log command in order to see really exactly the information that you want. You can also limit the number, like say you just want to see the 3 most recent commits. You could do git log -3, and here you just pass it any number. If you wanted to see the last 10, you could do 10. In this case, we're just going to see the last 3. Actually, let's limit that. Let's say git log, 1 line, but only give me the last 3. Okay. You can also use the P or patch flag to give you the actual differences that were introduced in each commit. And if you use regular expressions, you can actually grep through the commit messages for each. So if you're looking for a really specific commit message, you can find those pretty easily using grep. Okay, so at this point, we've learned how to create a new repository. We've learned how to create some commits. We've learned about the move command, the add command. We've basically learned just enough to get ourselves into a little bit of trouble. So I really want to cover how to recover from mistakes. So say you left a file out of your last commit. Our last commit here was... we renamed the move file to move.txt. So let's say we also meant to add another file in there. So let's just create an empty file. And then we'll add it to our index. And now we don't want to create a new commit. We just want to amend our previous commit. So we can say git commit amend. And then this is going to send us to our default text editor where we can also edit the commit message that we put in there. In this case, we're going to say we renamed move.txt to moved.txt and also add test.txt. We'll close out of there. And that will modify our most recent commit. And we can confirm that with git log. And you'll see that that we've updated the last commit that we created. If we look at the last two, the one that existed before it no longer exists. We've essentially replaced the last commit with a new commit using the amend command. Sometimes you want to, you don't want to have to retype the commit message. It might be something really simple like a typo or something like that. You can pass it the no edit command, and that will just replay the same commit message. If you want to only update your last commit message without changing any of the files that were in it, you can type git commit amend and then pass it an M flag. Updated some stuff. And that's just going to change the commit message. It's not going to change it's not going to change anything else about the commit other than the commit message. So that's really useful if you've made a typo or you forgot to talk about something in your commit message. Okay, so say you've just massively screwed up a file and you just want to reset it back to whatever it was in the last commit. You don't want to change all of your other files, but you just want to change a single file. You can check that file back out using Git Checkout. So we've got an index.txt. Let's overwrite it, and we'll just put in some gibberish in here, and we'll overwrite the index.txt file. So now if we look inside of it, we see the gibberish that I just typed in. But say we don't want that. We just want to go back to what it was at the last commit. We can check that file back out. So we'll say Git Checkout, and then we provide 2 dashes to distinguish that this is the end of the arguments for the command, and now we're going to just be passing it files, and then we'll pass it the index.txt file. Now if we cat that file back out, we'll see that it's right back to what it was before. This is really, really useful. I use this one all the time. If maybe I've been working on something and I decide I don't want this. I'm never going to want this. I've screwed up miserably. I just want it back. It's really useful. So the next one that I like to talk about is the ref log. Ref log is like the coolest thing. You can't lose anything with the ref log. So what it is it's a history of every single time you've updated your, every time you've like switched branches or made any commits or anything. All of the history is kept, I think, by default for 30 days. So when you type git ref log, it's going to give you an output of every single thing that you've done. Here we see a history with a lot of commits, but we can even see history that we checked out a branch. We switched branches there from test branch to master. We can see all of our history for the entire previous 30 days, every single move that we've made. You can also overwrite this functionality to make it last even longer or shorter if you want. But say we want to go to the state where we added this move.txt file. Say we didn't mean to rename it. All we have to do is run our reflog command and find the commit message that we were looking for. In this case, this is the abbreviated hash of the commit, and this is the index of that head pointer. So we can check that out. We can say git checkout head at index, which in this case is 3. Now, this is going to put us in what's called a detached head state. Basically, this means that any changes that you make here, they're not going to be reachable by any branch. Remember, a branch is just a pointer to a specific commit. Well, here we've kind of gone outside of any branch pointer. So we can make commits here, but if we want to actually save those changes and store them anywhere, we really have to create a branch. But if we do an ls command, we can see that we still have that move.txt file. So say we wanted to do something with this file or recover it in some way, we can almost always get it back using the ref log. Okay, so let's switch back to our master branch. Okay, so say we've accidentally staged a file and we want to unstage it. We can use the reset command to do that. Reset has 3 options. They are hard, soft, and mixed. The soft reset, which looks like this, git reset soft, this is only going to update your, it's only going to update your branch pointer. The mixed option is going to update your branch pointer and your staging area. Neither of those two are going to touch your working tree, so they're not going to actually overwrite any files in your current directory. These are the safer options to use. But you can also do a hard reset, which essentially takes a file and sets it back to what it was for whatever you're passing it in, which in this case we want to pass it in the head option. Okay. So if you want to undo your last commit but leave your changes, and I probably should have covered this one first because it makes a little bit more sense. If we do a ls command, we'll see that we're back to where we were earlier. We've got our moved.txt and our test file. And if we do our git log, and let's view our last two commits, we can see that these are the last two commits that we've made. We'll say we want to just blow this commit away or take our head and move it back to the commit that we were at previously, right? So we can do a git reset soft head, and then we're going to pass it the tilde here, which means one commit behind where we are right now, right? This is equivalent to writing head tilde 1. You could do head tilde 2, and that would move you 2 commits backwards, right? But it's going to leave your working tree as it is. It's not going to overwrite any of the files in there. So if we do git reset soft head tilde, and then we do another git log, we'll see that we've moved back one commit, right? Okay, so if you want, say you've made a commit that you meant to make on a new branch, you can do that by creating a new branch and then doing a hard reset, which sets your current branch back one commit, overwrites all the files, and then you can switch back to that new branch using the Git Checkout command. This is really, really useful. I like to use this trick because I tend to do that sometimes. I'll go and I'll make some work, but I'll forget that I meant to change branches, and I've already made my commit. This is just kind of a shortcut to get around that. Okay, so we've gone through quite a few basics. It's time to really start working with remote repositories. Right now, all we've done is we've worked on a local repository on our own machine. Where Git really gets powerful is when we start working in a more distributed manner where we've got repositories that live somewhere out on the internet. So a remote in Git in Git terminology is a reference to a version of your project that's hosted on a network location or somewhere on the internet. Working with others on shared projects such as open source involves pushing and pulling data to and from these remote repositories. A project may have any number of remote repositories. When dealing with open source projects on GitHub that are shared among collaborators, a local project typically has at least 1 or 2 remote repositories configured. Before we can start working with remotes, we need to kind of move out of our local repository. I've created a sandbox that we can use for today to play around with, and we're going to go and clone that. So before we do this, we want to make sure that we switch up to our directory that holds all of our Git repositories. We don't want to create a Git repository within a Git repository, right? So let's change to our repository directory, which in my case is just documents GitHub. And now we're going to clone a new repository, which is going to create a new folder for us and then clone this remote repository into it. So I'm going to paste this link into Slack, and if any of you guys are following along, that is what you will use to clone this sandbox that I've created. Okay, so let's clone that, and actually let's make sure that we're not, we don't have a folder that exists already. Okay, let's remove that. Okay, So here we're going to use the clone command to clone this remote repository that lives on GitHub. It's going to create a new folder that's going to be named after the repository, and it's going to take everything in that remote repository and copy it down to our local machine. Okay, so now that we've got a clone, let's change directories into it. Okay, so if we inspect what's in here, I don't think there's much. There's a license, a README, and then a sandbox folder. The sandbox folder, just kind of feel free to do anything you want in there. That's what it's there for. Okay, so what we want to do here is view the remote repositories that we have configured for this project. We're going to use the Git Remote command to do that. If we type remote, we see origin here. Origin stands for the original repository that we cloned from. Really what this is an alias so that we don't have to type that full long URL every single time. When we want to refer to the origin repository, we just say origin rather than having to type in that whole long string that we pasted in earlier. If you've cloned a repository from somewhere else like we just did, you're always going to have that origin repository. Git sets that up by default for us when we use the clone command. You can also view all of the URLs that Git is going to use to read and write data to and from those remote repositories if you pass the V option to that remote command we used a second ago. So here it's going to tell us the URL that it's going to use for fetching data as well as the URL that it's going to use for pushing data. So once you've committed changes to a local repository, your next step is going to be to push those changes up to the remote. To accomplish this, Git gives us the push command. So let's play around with working with that. Let's make a commit on this local repository and then push that commit up to GitHub. See, we're already in the sandbox directory. So we can see we've created a new file here, firstpush.txt. Let's add it to our index. And then make a commit. Okay, so now we're going to push that commit up to our origin repository. So we're going to say git push origin master. Now, if any of you guys are following along, you probably at this point will get a permission denied error. That's because you don't own this repository, so you don't have write access to it. We're going to cover how to get changes that you make on a repository that you've cloned into someone else's. But just for now, just know that you're not able to push to this repository because you don't have write access to it. So in the above commands, what we did was we created a new file, we committed it, and then pushed it up to the origin repository on the master branch. When we make the push, Git just gives us some output to tell us what happened. In this case, I think that commit already actually existed because I was going through it earlier, so it didn't tell us that it actually pushed anything out, but we'll see what the actual output of that command normally is here in just a little bit. So Git also comes with a credential helper that's going to help you manage those credentials. Whenever you push over HTTP, it can be a pain because Git's going to force you to authenticate every single time. And we don't want to always type in our username and our password every single time we want to push data up to a remote. We kind of want that to be cached. We can use the configuration file. There's a credential.helper that we can use to store those credentials. Now here I didn't have to authenticate because I already have that set up, but you can use this command here to change those settings. That way, if you do a push, it's going to ask you to authenticate once, and then depending on how you set it, it may not ask again, or it may ask after a certain period of time, but it's not going to ask you every time. So we'll say git config global, and then credential.helper, And then here is where we're going to pass in the value that we want to use here. So if we use the cache option, that's going to store your credentials for 15 minutes. That's what the default is. You can also pass it an option in seconds for how long you want it to store those credentials. So you can say cache timeout is however many seconds. So if you wanted to extend that 15 minutes to 30 minutes, you can type 1800. So you can also use the store command here. So if we back this up and go back to where we were, we can say git config global credential helper store. This will store your passwords indefinitely, but just take care when you're doing this because it does store these passwords in a plain text file on your computer. If you don't want to do that, if you're on if you're on a Mac, you can actually store this in the OS X keychain. There is an option for that, and there is an option on Windows. You have to install some other software, but Windows also has a credential helper that will store your credentials in an encrypted format. But just make sure that if you're working on the command line with Git and you're having issues where you got to type in your username and password every time, that there is a way to get around that. Okay, so the clone command that we used earlier, it implicitly added that remote origin for us, or that origin remote for us. If we want to explicitly add our own remotes, we can use the Git Remote Add command. So we'll say Git Remote Add the name of the remote that you want to use, and then its URL. And that will add I don't have one here, but, oh yeah, I do. So say we wanted to add a remote that pointed to like the Free Code Camp Oklahoma City website. We can do that by just passing in that URL and oops. And we want to give it a more descriptive name. So this is useful for if you've forked a copy of a repository, and we're going to talk about that here in a minute, and you've cloned a local copy of that fork. You're also probably going to want to configure this upstream remote. This is useful for staying up to date with changes that have been made to the original repository that you forked from. So this command that I've pasted in here, it's not relevant to the project that we're working on right now, so we're not going to add it. We're just using it to kind of illustrate that this is how you use the remote add command to add new upstream repositories. So Git and GitHub do support a variety of different protocols. In the example above, we specified the HTTP protocol. It's the most widely used, but it does have its downsides, like the credential issue that we talked about a minute ago. They also support Git and SSH protocols, and then Git supports a local protocol as well. And I've included a link here if you want to learn more about using some of those other protocols. A lot of people prefer to use SSH. It's a lot easier because you can use SSH keys, and so it's a little bit more hands-off once you get it set up. So if you want to do that, then you can learn more about it here. So when we're working with remotes, Git doesn't allow us to push changes up to a remote branch that's gotten ahead of the local branch that we're working on. This means that any new commits that have occurred on the remote branch have to be merged into our local branch before we can push those changes out. The Git Fetch command tells Git to go out and get data from a remote repository. You can optionally fetch data on a specific branch by specifying the branch name that you want to fetch after the remote. So here we've got our origin repository. If we wanted to fetch any changes that may have occurred out there, we can type git fetch origin. And that will pull down any changes, but it's not going to update our working tree. It's just going to store those changes in another place that we can then merge in later. So, like I said, it doesn't make any changes to your working tree. Once any new commits have been fetched from the remote, we merge them into our working tree using the merge command. So we can say we just fetched our origin. We can make sure that we're on our master branch. and then git merge origin master. This would merge in any changes that have occurred on that remote repository into our local repository. So we can also fetch and merge at the same time using pull. Instead of doing all that, we could just type git pull origin master. I tend to stay away from, what have I done? Oh, does this have to be? Yeah. Sorry, that's a typo there. There should be a space, not a slash. I tend to stay away from the pull command, though, because it doesn't give us an opportunity to review any of the changes on the remote repository before we merge them in. It may be that we don't actually want those changes that are out there, and pull does not give you that opportunity to review. Okay, so if you haven't been following along on your local machine yet, this is where I'd recommend that you start. So we've learned kind of all of the basic commands of working with Git, and now we're going to actually do some exercises to get a little bit of practice here. We're going to work through a little bit more of a distributed workflow. The sandbox that we just went through was a repository that we cloned. We're going to do a fork of another repository, make some changes to it, push those changes up, and then submit a pull request. So this is the workflow that a lot of open source libraries are used. This is how we would, like going back to the Free Code Camp Oklahoma City website example from earlier, if we wanted to contribute to that website, this is the exact same workflow that we would use to do that. So we're going to, I'm going to need a new tab here. I'm going to step through these exercises with you guys, and we're going to be cloning one of my repositories, so I've got to sign in with another account. Okay, so the first thing that we're going to do is we're going to create a fork. In the context of GitHub, a fork is a remote repository that you own that is a copy of a remote repository that someone else owns. Your fork is automatically linked to the repository that it was copied from. We're going to create a fork of a repository on GitHub, clone our remote fork down to our local machine. So our GitHub fork that we clone is what's going to be known as our origin. The original repository that we forked from is what's commonly referred to as an upstream. So, for example, if we wanted to contribute to Free Code Camp Oklahoma City website, we would fork their repository on their account, which would create a copy of it on our account, right? In this example, the repository that lives on their account is the upstream. The origin is the one that we own. And these two are linked together because ours is a fork of theirs. Okay, so what we're going to do is we're going to go to github.com/Bryce Jech/talks, and I will paste this into Slack here. So let's go to that URL. And this is the talks repository that has, the content that we've been going through today. So we're going to create a fork of that using the fork button. So just go up here and click fork. Yeah, is everybody tracking me? Yeah. So it's github.com. Here, I'll pull it up. So it's github.com/BRYCEJECH/talks. Okay, so whenever we go there and we hit this fork button, what it's going to do is it's going to take us to our own GitHub account where that fork is going to be created. So here we're on my alternative account that I set up to go through this with you. And we can see here that we've got a repository named Talks, and that it's been forked from Bryce Jech /Talks. That's the upstream repository that we forked from. Okay? So this takes you, like I said, to your own GitHub account where the fork is created. The URL is going to be github.com/your-username/talks. Okay, so once we're on that page, what we want to do now is click the green clone or download button, and that's going to give us a URL that we can copy to our clipboard. The URL should look like this. It's going to be github.com/your-username/talks.git, and I will do that here. So I'm going to hit the green clone or download button, and then here's the URL that we want to copy to our clipboard. We're going to copy that. And now here, I'm going to move out of my sandbox. I need to move to, because I've got a directory already called Talks, so I'm going to move up to an alternative GitHub folder. You don't have to worry about this part though. Okay, so now that we've copied this URL from the clone or download button, we want to type git clone and then paste that URL in and press enter. So now if we type in ls, we can see that we have a new Talks directory. And let's change into it. So here we've got 3 different folders. We've got a intro to Git is the one that we're interested in. So we want to switch into that. Okay, so the reason, like I was saying earlier, for creating a fork is that we don't have write access to the original repository, the one that I own, right? So creating a fork allows us to have a copy of a repository that we can write to that lives on the internet, and then this writable repository that we own is what we're going to use to create our pull request from. Does anyone have questions about that setup? It's kind of hard to wrap your head around at first. So if you have any questions, just let me know. So the first thing that we're going to do here is we're going to add an upstream remote. We probably won't actually need to use it today, but just to kind of practice adding it in there, we're going to go ahead and set that up. So we're going to say Git Remote Add Upstream, and then this is going to be the original repository that we forked from, right? So this is where we're going to go fetch any changes that may have occurred in case, like I said, if that repository gets ahead of us, we have to merge those changes in before we can send out a pull request or before it can be accepted at least. So we're going to type Git Remote Add Upstream and then the link to the original Git repository that we cloned or that we forked. Okay, so the next step that we're going to do is create a branch. We're going to do this because this is just like the typical workflow, so we want to work through it. So we're going to say Git Checkout B, which is going to create a new branch and switch to it, and we're going to create a branch called Survey. So here Git's going to tell us that we've switched to a new branch, Survey. Now, the next thing that we want to do is get into that Survey folder. So I'm in the intro to Git directory inside of the Talks directory. So we want to change to the Survey directory. Now, if you do an ls here, you're going to see a template.md file. You're going to copy that file to a new file name. Name it something that's not going to collide with anyone else. I would recommend that you use like your username, like your GitHub username, and make sure you give it an MD file extension. So if your username is Pink Unicorn, you can name the file pinkunicorn.md. So we're going to copy using the cp command the template.md file, and we're going to name it whatever our username is. If it's Pink Unicorn, it would look like this. Okay? Now, you're going to want to open this file that we just created, and then just fill out the survey questions. So if we wanted to open this file in Atom, we would just type Atom, and then we can pass it the current directory. So if we're inside of our survey directory, we've got our template.md. We're going to copy that. You can do this at the terminal, or you can duplicate it here. And I'm going to call mine, I'm going to name it after my username here. And it's an exact duplicate of what was in this template file. Okay, so now you can go ahead and fill that survey out. The first few questions are going to be just checkboxes. In Markdown, they look like this. It's just a dash and then square brackets with a space in between them. If you want to check that box, you just put an X in there, or you can just leave it as it is and it will be unchecked. The last few questions there are just free response. Just kind of type in there, just type your responses in there. So I'll fill this out here. So if we want to check one of these boxes, we just put an X in there. Right, is everyone following? It's just kind of questions about just some questions about yourself. It was easier to do this than to actually have like some coding challenges to solve. This talk isn't really about coding, it's about managing code and just working with Git. So this is something that we can just kind of get through more quickly so that we can get our pull request created.
Anybody need help?
Yeah, I got lost a while back. Sorry about that. When you're copying a template,
Uh-huh.
from that point on, I know it's not copying over. It looks like me usually.
Kimberly, you want to see what's...
Sorry about that.
No, no worries, no worries. Okay, so I've filled in some of these questions, and I've saved the file. So the next step is going to be to add that file to our staging area, create a commit, push that up to our origin repository so that we can create our first pull request. Okay, so we can see the copy that we have here. So I want to add that. Git Add. And then create a commit. And now we're going to push this up to our origin repository. Oops. And we are on the survey branch. So git push origin survey. Now here, we haven't created a survey branch on the remote repository. GitHub is smart enough to figure this out for us, though. It's going to go ahead and create that remote branch for us. So we don't have to worry about creating it out there first. If we create a new local branch and push it to a remote, it will create that remote branch for us. So git push origin survey. Oh yeah, I ran into this earlier. So it doesn't like, Git doesn't like me trying to use two different accounts to push to. So really quickly, I've got to set up I've got to get around that. Where is it? I just had it. Sorry, I was... Well, I cannot find it. So you guys shouldn't have this problem anyway. Basically, the issue is that I'm trying to use two different GitHub accounts at the same time, and it just does not like that. Did anyone have any problems pushing to their origin repository? No? Okay. So what we can do now is we want to create a pull request. So we're going to go back to our repository on GitHub and then hit new pull request here. What we want to do, oh yeah, we haven't pushed it out, okay. I'm going to fill this out locally, or on GitHub rather. And we will pretend that I've filled this out. Okay, so now that we have a change in here, we can hit this new pull request button, and it's going to take us to a page here where we're basically telling the owner of the repository that we want you to merge the changes from our fork into the repository that you own. So here, the base fork, this is the upstream repository that we originally forked from. We want to pull these changes into the master branch. Our head fork is the fork that we created. This is the one that we own. And then we want to make sure that we're using the survey branch that you created. I wasn't able to push that change out due to that credential issue that we were having a minute ago. You shouldn't have that problem though. Just switch to your survey branch. And then you can hit the create pull request button. This is going to give you a title. Just put something in there, something descriptive, and then hit create pull request. Okay, that's it. So now the original repository owner can go in and view that. If we go to pull requests here, we'll see that we've got a couple of pull requests. This is the one that I just created. And here's one that Kimberly has created. So now the repository owner can go in and accept those changes, right? So we can go in and merge those in. I, as the repository owner, have to approve that though. So I can just go in and hit merge pull request. And now the changes that she made on her remote repository now exist in mine. So if we can go in and confirm that, we can go over here to code, intro to Git, survey, and we should see the file that Kimberly created. Now this isn't on her fork, this is in the repository that I own. And that's really the simplest distributed workflow that you can really have with Git, where you're all pushing work to a shared remote repository without ever really affecting it directly, right? So you've created your own copy, you've created a branch to make some changes to, you've pushed them up to your copy and then requested that I, the repository maintainer, pull those changes in. Like I was saying earlier, this is how a lot of the open source software that you probably use is built. Going through and knowing how to do this is extremely valuable in being able to actually contribute to open source software out on the internet. So does anyone have any questions? Is anyone stuck? Have any questions about Git? This is really the end of the talk, so if you've got any questions that you want to ask, now's the time. Good? All right. Well, I will turn it over to Kimberly, who's going to have some announcements. Thank you.